Okay, so our goal for today is I will determine the rate of change. So we're going to take what we did on Friday and really start to connect it to things, okay? What did we also say that rate of change was on Friday? What was another name for it? Slope. Okay, so remember, rate of change is my slope, okay? That's exactly what it is. We're going to go into more about slope, but for now we're just focusing on the rate of change piece, okay? Okay, so we are going to look at these linear relationships to do this today. So this piece is going to lead you into your class activities. So you have a set of cards at your table, don't open them yet, but this is how you're going to connect your set of cards together, okay? So we are actually trying to connect the visual, the graphs, and equations based on rate of change, okay, with each other. Okay, so we're going to look at the examples here. I've got to zoom in a little bit. Okay, zoom out. There. Okay, so has anybody ever seen those? Talk to your table about what those are and how they work. Talk to your table. Okay, what do they do? What is so cool and mesmerizing about these that we love? Go ahead. You don't want to say what they do?
Oh, it's like a little tornado in a body. You glue on top of each other, and then you drill a hole, and then the water, it does all that extra stuff when it's raining.
Okay, yeah, it's like a tornado in the bottle. And you actually have to buy the actual little contraption to connect the bottle, or that water does not fall through like that. Otherwise, it's just like blah, 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 blah. This makes it be more consistent and actually does the tornado effect. What?
Oh, so actually, what's the purpose? Why would you need that?
I don't know. I don't know. Ask the science teachers that question. I don't know. I don't know. Okay, so we are looking at this relationship, and we are going to connect it to graphs and equations today based on the rate of change. Okay? Okay, so far we know that in this bottle there's a total of 6 units of water. That means there could be some on the top, there could be some on the bottom. In the picture, there is some on the top and there is some on the bottom, right? Okay? But there's always 6 units of water. So if there's 2 on the top, there's how much on the bottom? 4. When will there be the same on the top as there is on the bottom? 3. So when there's 3 on the top, there have to be a 3 on the bottom. Make sense?
Yes.
Yes, so in your cards, you're actually going to see pictures that look like this. And you have to think about what's going on at the top and what's going on at the bottom, right? Is water flowing out of the top or into the top? Out of the top. So flowing out of the top and into the bottom. So while this one is decreasing, this one is increasing. So that's going to be really important. Okay, so we're going to look at the graph and look at the relationships in the graph. So based on the picture I just showed you, if this was to represent one of those tornado bottles, would it represent the top or the bottom? Don't answer yet. How much water is it? Is it starting with or ending with or whatever? Describe the relationship to your table. Okay, so what's going on? Would it be the top? Would it be the bottom? How fast is it going out or going in? Okay, talk to your table and talk to them about how you know that. Okay, so. Okay, so what was our discussion? Let's answer the question. Does the graph show the flow of liquid out of the top or out of the bottom? Out of the top. Out of the top. How do we know that? It's decreasing. Great. Okay. What is the starting situation?
From 5 centimeters.
Okay, so if there's 5 centimeters in the top at the beginning, how much is at the bottom?
0. Or 1 centimeter.
1. How much did we say has to be there? 6, right? So there has to be 1 at the bottom. So it must have had some left over. They turned it over before it was done or something. Okay, so there must be 1 centimeter of water down at the bottom. Does the liquid flow at a constant rate of speed? How do you know? Yes. It does? What is it?
1 centimeter.
Do we agree that it's 1 centimeter per second?
Yes.
Okay. It's going from 5, 4, 3, 2, 1. Yes? Okay. Okay. And what speed does the liquid flow at? Oh, we already said it. I already said that. 1 centimeter per second. That would be our speed. Okay. Okay, so let's see, I'm gonna skip a little bit here. I'm gonna see if y'all can match. So every tornado image, like every one of those images, is going to have two graphs that match to it. There's going to be a top, one that represents the top, and one that represents the bottom. So two of these graphs belong to each other. Two of these graphs belong to each other. Discuss with your table which two graphs belong together in one.
I love this question.
Only two of them belong together. Discuss why.
Oh, I know.
One represents the top, one represents the bottom. Okay, so let's start by looking at some key features in our graph to help us, okay? So I'm going to go ahead and I'm going to mark all the starting points on my graph here. What is that called on my graph? Come on, y'all got it. Y-intercept. Oh, yeah. Very nice. Okay, so those represent all my y-intercepts. Now, first off, can G2 and G5 go together?
No.
No, because that would both be tops, right? Okay, so let's start with G2 since it comes first. G2 starts with how much water in the top? 4. So how much water has to be in the bottom? 2. Okay, so what does the y-intercept need to be for my second graph? 2. And it needs to be increasing, yes?
Yes.
Okay, what's my answer?
It would be G6.
G6. Why does it have to be increasing?
It's gaining water.
It's gaining water in the bottom. It's growing water from the bottom. At the top, it's losing water, and the bottom, it's gaining water. Make sense? There. Okay? Okay, so now let's look at the other details. How long does it take for the water to go out of the top?
1 second.
1 second. And 1 second, I have no water. So what's my rate of change? It's going from 4 to 0 in 1 second. What's my rate of change?
4 centimeters per second.
4 centimeters per second. Okay, so my rate of change is 4 centimeters per second. Does anybody know what this is called on my graph? X-intercept. This is called my x-intercept. This is really important. It's also called my zero. When we get into other functions, there's going to be more than one of them, so there'll be zeros. So it's called the zero of my function. Why do you think it's called the zero of my function?
Can just define it.
It's really literally when it equals 0, when the function equals 0. Yeah, it's when y equals 0. There's no water in that bottle. Okay? Yes.
Okay. So you know when you said there has to be like 4 on the top and 2 on the bottom?
Yes, so 4 in the top. At the very beginning of the relationship, at 0 seconds, there's 4 water in the top. And at the very beginning in the bottom, there is 2.
Oh, I thought you meant like there's like a top.
If we were to overlap these graphs, they would create like an X of each other, and they would intersect each other at 3. We're going to intersect, not at 3. Well, yeah, when there's 3 inches of water, or 3 centimeters of the water in the top and the bottom. Okay, because we said that's when they'd be equal, yes? Okay. Okay. Any other questions about these? Okay, so if you would please go ahead and find your picture or your cards. Okay, and I'm going to give you a little bit of guidance with these, a little bit of guidance. Okay. If you would please go ahead and start by separating all of the pictures into a pile. Okay. Turn that back on. These cards are going to match to 2 graph cards. So now go ahead and sort your graph cards into two piles. One that would represent the bottom where it's increasing, and one that would represent the top where it's decreasing. So I'm going to put these in two piles. And then you're going to have an extra one that's blank because there's one picture that there's no graph for it, and you're actually being challenged to draw it for yourself. Okay? Okay, the last thing is to actually look at the equations. But before we do that, let's all just start with one graph and then we'll figure out the equations together, okay? Actually, I changed my mind. I'm going to go back to our picture here. I'm going to go back to our graph that was given to us, and we're going to write an equation for that graph, okay? Okay, so if I were, this is the last thing, if I'm talking about the top of my graph here, y'all already told me the rate of change here was 1, yes? Really? Are you kidding me? There we go. Okay, the rate of change here was 1, yes? Okay. Is it increasing or decreasing by 1? Decreasing. So how do I actually want to write my rate of change?
-1.
-1. -1 what? Centimeters per second, yes? Okay, what variable represents my seconds here? T. T is my seconds. T for time. Okay, so if I want to write my rate of change, the height equals, it's going down 1 per second, yes? Okay, there's a piece missing here though. Is it just going down 1 per second? How do I describe where I'm starting from?
Where the
I'm starting from 5, so how do I describe that in my equation?
plus 5.
Plus 5. You remember that? Yes? Okay, so my rate of change belongs in front of my variable, and my y-intercept is going to belong on its own. Yes? This is the thing I'm adding. Okay? Now, if I was looking at my, what were you going to say? The -1, T is X. T is X, but we're using the letter T. -1 is my rate of change. Do I need the 1 there? Can I just have -T? Yes. You don't need the 1 there, you might not see it. Anything times 1 is itself, okay? Okay, so there are going to be 2 equations with every picture because you're going to have, there's going to be an equation with each graph. You're going to have your graph that's decreasing, and you're going to have your graph that's increasing, yes? Okay. Okay, I'm pressing record, or I'm pressing pause. What I want you to do is start sorting, okay? Start sorting your graphs with the equations that belong with them, like trying to get your graphs with the proper pictures. Does that make sense? I feel like I'm giving awful directions. So we're matching 2 graphs with each picture, and then matching 2 equations to each picture. So there'll be 5 cards, or 2, 4, 5 cards together. Okay? Okay. Okay. Okay, so if I'm looking at my different graphs, if I start with this picture, F1, it says the change in height is 1 centimeter per second. Yes? Okay, and the top is starting at 6. It's decreasing 1 centimeter per second. So if I look for a graph that matches that, I have to find a graph that starts from 6. And now this X and Y axis, this X axis is not labeled. But the other one was ending in 3 seconds. I need this to be all gone if it's 1 centimeter per second in 6 seconds. So I can number these myself since they left them blank for me. 2, 4, 6. Right? In 6 seconds, all of my water is gone. Does that make sense? Okay, so then I need a graph to represent the bottom. The bottom is starting from what? 0. How long will it take for it to have 6 centimeters of water? 6 seconds. So I'm going to find my matching graph. In 6 seconds, it's full. And then I'm going to match equations that go with both of them. This one goes with the top graph because it's decreasing by 1 per second, and it's starting at 6. This one goes with the bottom graph because it's increasing by 1 per second and starting at 0. Okay? So my y-intercept, or my starting point, is located here. My rate of change is the number that is coming before t. In this case, that's 1. Okay? It's the coefficient to our variable. Does that help a little?
Yes.
Okay. Now go back and see if you can make some more connections. Okay? Okay.
I feel like I'm so